When you have completed the installation of the primary system and all of the joints have cured, you are ready for pressure testing. It is critical that you use a calibrated gauge that is in good condition for this test. Use a gauge that has a full-scale reading no more than twice your test pressure. Install the gauge on the pipe in the tank sump or at the last dispenser in the line. Using a regulated air supply, slowly pressurize the primary system to the desired test pressure, normally 50 to 60 psi. Close the valve and watch the pressure gauge. If the line will not maintain pressure on LCX pipe, you can use soapy water to inspect each fitting and pipe for leaks. Spraying the soap solution on each end of the containment jacket will result in a complete inspection of the pipe length. Be sure to include gauge connections, shear valves, and other components in the inspection. If the primary system is holding pressure, you are ready to proceed with the closure of the secondary system. If a leak has been found in a pipe wall, repairs can be made. The method employed depends on the severity of the damage and the type of pipe. For single-wall pipe, reference to these methods is found in Bulletin 7501 in Section 9. For LCX pipe, Section 10 of Bulletin 9903 should be used. For minor damage to 3000L pipe, remove the damaged area with a hole saw and sand the surface of the pipe that will be bonded to a half-repair coupling. Apply adhesive to the bonding surfaces and to the cut edge of the pipe wall, and assemble the repair coupling over the pipe. Be sure to align the flanges of the repair coupling at 90 degrees to the location of the hole. For moderate damage limited to less than 3 inches, remove the pipe section affected and sand the surfaces to which the half-repair coupling will be bonded. Apply adhesive to all bonding surfaces and to the cut edges of the pipe, and assemble the repair coupling. For major damage to a length of pipe, cut and remove the affected section of pipe and replace it with a new piece that is at most 6 inches shorter than the section removed. Sand the bonding surfaces of each pipe end and the inside of 2 half-repair couplings and apply adhesive, including on each of the 4 cut pipe edges. Assemble the repair coupling pieces. Allow the adhesive to cure in all cases before testing. For LCX pipe, if the damage is confined to less than 1 inch of pipe, remove that portion and cut back the jacket on both sides of the cut and taper both primary pipe ends. Install a primary coupling using standard procedures and allow the adhesive to cure. When the adhesive has set and testing is completed, assemble a containment coupling over the repaired primary section, again using standard procedures we will describe in a few minutes. For LCX sections greater than 1 inch, remove a minimum of 15 inches of pipe, or the full length of the damage, whichever is greater. Cut the jacket off the ends of the remaining installed pipe, and from a section of LCX pipe that is to be used for replacement. Taper all pipe ends and dry fit with 2 primary couplings to assure proper fit. Assemble both primary coupling connections and containment couplings over them using normal assembly procedures. All Dualoy containment systems use 2-piece clamshell fittings. The clamshells are paired with 1/2 of the pair containing the pre-inserted propeller nuts in each hole. This allows the halves to be assembled by working only from one side, if full access is restricted. Should it ever occur that you end up with both halves of the clamshell containing the propeller nuts, the nuts in one of the halves can be removed by partially threading a bolt into the inner face of the clamshell hole and nut, then tapping the head of the bolt with a hammer to drive the nut off the fitting. As with the primary system, all bonding surfaces of the containment system should be clean and freshly sanded prior to bonding. The bonding surface of the jacket on LCX pipe may need to be located by dry fitting the clamshell over the primary fitting and marking the correct location on the jacket wall. Also, as on the primary system, all surfaces must have adhesive applied to them for proper assembly. Do not over-apply adhesive to one surface, expecting that to be adequate to wet out the other surface. The flange surfaces, round surfaces on the fittings where the pipe will bond, and the pipe walls all need to be coated with adhesive. The primary bond is a taper-to-taper bond, requiring very little adhesive to seal since the bond line is very thin. The bonds between clamshell halves and with the pipe, however, are flat surfaces to flat surface bond. These require somewhat more adhesive to ensure a full seal is achieved. The full surface of all bond areas must be coated with adhesive to the point where the adhesive is opaque and the fitting or pipe does not show through. Small brush marks are acceptable, but generally the surface shows only the adhesive color. This is especially true for the flange surface inside the bolt holes. Once the adhesive is applied correctly, the clamshell half with the propeller nut should be put in place. The other half should then be fitted directly onto it so easy access to the holes is provided and the bolts can be started into the threads by hand. All bolts should be assembled to near the final position before full tightening is done. This can be done with a cordless drill in a socket or other device. Impact wrenches should not be used for this purpose. Final tightening should be done by hand with a nut driver, socket wrench, or other hand tool. This gives the installer a good feel that the bolts are all uniformly tightened. Final tightening of the bolts on elbow clamshells and T-clamshells should be done from the inside radius or branch side first. This will help assure proper fit and tightness. Fewer bolts are placed along these sides. If the outer bolts are tightened first, the fewer bolts on the inside are pulling against the greater number and may not be able to fully close the clamshell. As the assembly is completed, excessive adhesive should be squeezed from all bond surfaces. This can be scraped from the bond lines for future use with either the spatula or a gloved finger. As before, this action helps assure a good seal all around the assembly and removes any surface bubbles in the adhesive that may occur. LCX clamshell fittings are dimensioned to ensure the bond of the pipe jacket is displaced away from the cut jacket to prevent excessive adhesive from closing off the interstitial space between the pipe walls. An inordinate amount of adhesive would have to be used to block that jacket and cut off the fittings. The termination sleeve cannot be designed with this same spacing. More care is needed with the amount and location of the adhesive on these parts. The part is, however, designed to be easy to install. The larger opening on one end of the sleeve, where the jacket layer fits, has two shoulders, against which the cut jacket is to butt. These shoulders prevent the jacket from being over-inserted in the part and ensure that the test port, if included, is open to the containment space. Adhesive used on the large end of the fitting and on the jacket should be applied with a small space between the bond surface and the shoulders in the fitting, and the end of the jacket cut on the pipe. This will prevent any blockage of the end of the jacket. In the same way you tested the primary system, use a regulated air supply to slowly pressurize the secondary system and observe the gauge. We recommend 30 psi as the test pressure to differentiate it from the pressure in the primary, but no more than the rating of the least component, such as if flexible sump penetration fittings are used, should be applied to the system. Observe the gauges on the containment system for decreases or increases. A decrease would indicate a leak in the containment system. An increase would show communication between the primary and the containment. Such an increase on the 3000L contained system would be approximately the same as the drop for the primary pressure. For the LCX system, a 1 psi drop in the primary can cause as much as a 15 psi rise in the containment. This differential is another advantage for the LCX system, a definite reading of system integrity for both primary and secondary containment. During either pressure test, you should remember that the cooling of the system, such as might occur overnight, can cause an observed pressure loss. A pressure gain is likely due to heating by the sun. The most common causes of leaks are improper or leaking gauges, flex connectors, and undiscovered impact damage to the pipe. A pressure differential of 20 psi between the primary and secondary systems is adequate to test the integrity of both systems. Small leaks into or out of the secondary containment system will be very obvious on the pressure gauge for the LCX system. In the unlikely event that a leak should be detected, a soapy water solution sprayed on the system will normally pinpoint the source of the leak where bubbles are observed. The secondary containment fittings may need to be removed to check the primary, if there is an unexplained pressure gain in the secondary system. When testing is complete and your inspector is satisfied with the installation, the piping and containment system is ready to be closed in and backfilled. In this program, you have seen a review of the installation techniques for Amaron Dualoy 3000L and 3000 LCX fiberglass pipe. Be sure to read Amaron Bulletin 7501, 8702, and 9903 for a complete discussion of all Dualoy system installation. Also, pay particular attention to the instructions packed with your adhesive kits and power tools. Amaron assumes no liability for injuries resulting from the misuse or abuse of its products or the misuse or abuse of tools used to install its products. For more information on Dualoy 3000L, LCX, or other Amaron products, contact your Amaron distributor.